I'm recording now. All right, 6.6 is about the fundamental theorem of algebra, and it's in old English font, so it has to be important. Yeah. Okay, so the fundamental theorem of algebra is basically when you have a polynomial that is to some degree, you will have that degree, you'll have that many roots, right? And we already know that. Like a cubic function has how many roots? 3. Okay? So like a polynomial that's to the 10th would have 10 degrees. Okay, so that's the point of this. That includes multiple roots, okay? So like if like the root 3 happens 3 times, then that's included in there. So we are going to do the same thing we did yesterday and find all the zeros of this polynomial. So we're going to use that rational root theorem to go with this. But the knowledge that we're putting together is what you learned about conjugates at the very end of it, okay? If you have one conjugate, you have to have its other half, right? Its pair. Okay, so those travel in 2s, correct? All right, so thinking about that, how many total roots will this one have? 3. So if it has an imaginary root, how many will it have? 2. So it could either have 1 rational root, because that'd be the leftover one, or 3, right? It wouldn't have 2 rational roots, because that would mean it only had 1 imaginary, which can't happen, because imaginaries happen in 2s. Okay, so that's kind of our knowledge here, is knowing that we either have 1 rational root or 3 rational roots. And going into this, maybe that'll kind of help us and save us some steps. Okay. Yes.
Is it 1 or 3 just because it's x to the 3rd, or like if it was x to the 4th, would it be 1 or 4? It would still be 1 or 3.
Well, if it was x to the 4th, it could be, because think about the imaginaries and then use that to tell you about the rational. So if it's x to the 4th, it could have 2 imaginaries or 4 imaginaries, right? They're even. So that would leave us, if it was 4 imaginaries, how many rationals would we have? None. Because 4 is the highest number we can get, right? Okay, if it had 2 imaginaries, then how many rationals would we have? 2, because it's got to add up to 4. If we had no imaginaries, how many rationals would we have? 4.
Were you saying like imaginaries? Is that what we did yesterday?
At the very end. Yes, with the eyes. Or it could be the complex ones with the crazy square roots that you can't simplify. Okay. So we're just practicing like thinking these problems actually through. So now we got to do our rational root theorem to figure out our rational roots. Okay, so do you remember how to do that? Okay, so what is P? And what is Q? 1. Okay, what are the factors of that 2?
2 and
Negative 2, 1, and negative 1. Okay, and then our denominators, options are 1 and negative 1, right? Okay, so if we're going to make fractions out of those, remember it's P goes on top, Q goes on bottom. So we can have 2 over 1 and 2 over negative 1. We can have negative 2 over 1, negative 2 over negative 1, 1 over 1, 1 over negative 1, negative 1 over 1, negative 1 over negative 1. So I get 2, negative 2, that repeats, 1 and negative 1, those repeat. So how many possible rational roots I have 4 different ones that could be it. Okay, so now we gotta test them. How do we test them? The synthetic division. Okay. So now we test them. Okay, which one you want to do first? Just go in order. Okay, so 2, what are my coefficients? 1, 1, -1, and 2. All right. So bring down your 1, multiply, get 2, add, get 3, multiply. I don't think this one's going to work. Nope. Okay, so not that one. Okay, so now we're down to 3 possibilities. -2, okay. Using my same coefficients. 1, -2, -1, 2. Ooh. Yes. I got that one to work. Okay, so we have 1 rational root we know of. So what that leaves us with is x squared minus x plus 1. So that's what we're going to test the other one on, others. Okay, so I'm going to use 1. And my coefficients are 1, -1, and 1. That one didn't work. Okay. I have a thinking process going on here. So we have found 1 rational root so far, and how many possibly could we have based on what's left? 2, right? Because there's only 1 more possible option. But did we say we could have 2 rational roots? No, it was either 1 or 3. So automatically, the other one is not going to work. -1 is not going to work. Do it? Because the other one would be a imaginary, right? And imaginaries work in pairs. Okay, so yeah.
Why would it be imaginary?
We're saying, like, why could we possibly have it? Or so your options are complex. Maybe it could be that square root thing. It doesn't necessarily have to be imaginary.
Okay, so like if it was like a negative in the square root, it'd be imaginary. But then that'd have to
Yeah.
be 2.
Yeah, there had to be 2 of those, and we have a maximum of 3. So if we had 2 of those, then that means only 1 rational. Okay, y'all are doing good thinking. Okay, so we're done with the rational part. Now we are going to figure out the complex roots. And the equation that we have left to work with is the x squared minus x plus 1 equals 0. That is what we are factoring. And it is quadratic, right?
Yes.
Okay? We know we can't truly use our factoring method, because if that would have worked, then we would have had rational roots. So we can either do quadratic formula or complete the square. What do you want to go with? Quadratic formula. Do you remember it? Very good, you two. Okay, there is quadratic formula. Again, I will give that to you on the test. I will not make you memorize that, though obviously you use it enough to be good. Okay, so what is my A value that I will plug in? What is my B value to plug in? And C is 1. All right. Do it, and let's see if we get the same thing. Hmm?
Is that one more step? Like after this one?
This is it. So I got x equals 1 plus or minus I squared of 3 all over 2. Is that what y'all got? Okay, so there are our two imaginary and crazy square root. Okay, it actually has both of it. There's there's 2 roots and there's 1 root. So that is our 3 total.
So for your answer would be -2 and that?
Yep, so your answer would be -2 and this thing. That's all you gotta do. So really, you did these types of problems yesterday, right? Okay, I just wanted you to add like that element of thinking about it, and because you can kind of save yourself some steps. Like we got to skip that. Yeah.